combining like terms in multi-step equations. So when you first think about this, we have to know what each of these things means, right? So we say, well, that's the first thing. What does a like term mean, right? So if anything is like, then it means something, right? What does it mean that we are like each other, right? We are both humans. So if something is like term, okay, then we say I there needs a bigger dot, that it has the same variable or term. Sometimes we'll say that, right? But this usually is some number or letter. Okay, so it could be x, y, z, or something like that. Okay, so that's pretty basic here, right? So then if we are going to combine them, we'll go as we go along. We'll do an example, and then we'll explain as we go. But first, I have 3x plus 8 minus 2x plus 8 minus 2x. And then on the other side of the equation, I have 17 plus 8x minus 23. Okay, so we can agree our terms here are x's. Okay, so we can highlight them real quick here. And then we can also see that we have numbers, okay, and the numbers, I don't know, we could say they're like as well, right? They are like, they are not the typical ones that we think of as terms have variables, because, well, they don't have variables, and so they just combine like regular numbers. Oops, I forgot to write this one here, right, 17 as well. So then the first step here's to combine on each side, right? So that's our first step. So to combine on each side. So that's number one. Combine on each side. Combine on each side. So it's important to notice here is that this is 3 times x and this is 2 times x. And same thing with this 8x on the other side, it's 8 times x. So when I combine these, it's just like if I had 3 of something and I'm subtracting 2 of something. So that means, and I'll put this in red here since we highlighted in red, that means that I end up with 1x, right? Because I did 3 minus 2. And then I have simply plus 8 here. Then on the other side, I have 17 minus 23. So again, right, as we learned with negatives, if I have 17, it's like I have $17 and I spent $23, so that gives me minus 6. And then I'm left with positive 8x. That was what I already had, so I didn't have to combine anything. Now, what do we do here? All right, we move terms here now. And so this one right here, I don't have a whole lot of room to write my number 2 here, but I can just simply say here that number 2, I'm going to assign sides. Okay, so I'm going to assign sides. So I'm going to put 2 here. Assign sides. So assign sides. What do I mean there? Well, if I have a room full of boys and girls, and I want to count how many I have of each one, right? Then I say, well, why don't you move to this side if you're a boy, and move to this side if you're a girl, right? Let's separate them. So let's just go ahead and say, for my purposes, that my variables are going to be, I don't know, I already have the most of them over here, so I'm going to say that my variable x's are going to be over here. So I'm going to put a v there. I'm going to put c over here. Okay? So if my variables have to go on the right side, that means they have to come off of the left side. Okay, so let's use my red again. And so in order to get rid of them, right, again, algebra is a lot about opposite operations, right? So how do I get rid of something that I don't want? Well, I have to do the opposite. I have to take it away. So I'm going to take away 1x, and I have to take away 1x on this side. I didn't break any math rules, okay? So that means that I'll end up with 7x here. And over here I had no x, right? Because they were subtracted. So, right, our equation here, so if I go back to equation is a balance, okay? So I should have the same thing on one side as I have on the other side. Alright, back to this, right? So now my variables, right? My variables need to be separated as well. So if I want all my variables to be on the left side, which I put the c there for constants, okay, they're always the numbers that are given there, and I should say plus 6 over here to get rid of it, right? That's opposite operations. And then I can say plus 6 here. And so then I'm left with nothing other than 14 over here and 7x over there, right? Maybe I should write these a little closer to each other. But anyway, equals, okay? And so if that's 7x equals 14, what do I have to do? Well, what does this 7x mean? It means 7 times x. And so that means that my 7 here needs to be divided on this side, because if I divide 7 by 7, I get 1. And if I divide 14 by 7, I get 2. So that means that I get 1x is equal to 2, right? And typically, the way we reorganize this, we actually would say, oh, you know what? It looks better to say x equals 2. But I really don't have anything different in this way, right? It's just written a little differently so that it might be clear. But I accept either one will be fine as an answer, okay? So then this brings us here, right? You say, well, why don't you put a 1 in front of this? Well, I can put a 1 here. But if I tell you that I have a dog at my house, then you assume that I have one dog, right? So if I say that I have x, that means I have 1. So that leads me to the last thing, which is that if you see no number, so if you see no number in front of a variable, okay, you see no number in front, it is 1. Okay, that way you don't get yourself confused, because then if you you have something like x plus even x, right? Say, well, how many x's do I have? Well, I have 2 of them, so I have 2x. And again, I don't change my variable at all, right? All I have to remember is that I have a 1 right here, and I have a 1 right here. Alright, that's it for this topic here.